In example 7, we're going to rewrite 1 over 1 plus cosine of x as an expression without a fraction. So the whole goal of this problem is to rewrite this with 0 fractions. So step 1 is always to rewrite the problem so you can start working with it. If you remember when you wanted to get rid of a radical in the denominator like this, you would multiply by the conjugate. So we're going to do the same thing. We're going to multiply by the conjugate of the denominator, which is 1 minus cosine of x. So now we're going to multiply those out. So in the numerator, I'm going to get 1 minus cosine of x. And in the denominator, when you multiply by the conjugate, you're going to end up getting 1 minus cosine squared of x, because the middle term ends up going away. Once you see this, you should scream Pythagorean identity. So our identity that goes with cosine is sine squared plus cosine squared is equal to 1. So I want 1 minus cosine squared. So I'm going to subtract cosine squared from both sides. And I'm going to get sine squared is equal to 1 minus cosine squared. So I'll put that in a box. So 1 minus cosine squared is equal to sine squared. So now I'm going to rewrite my fraction as 1 minus cosine of x, all divided by sine squared of x. So again, 1 minus cosine squared turned into sine squared. Now the question is, how do you create no fractions with this? Well, we're actually going to break apart the fraction. So this is going to be 1 over sine squared minus cosine of x over sine squared. It's kind of unintuitive, but this is how you do it. If you were to combine these, you would get that, but we're going to do it in reverse. We're going to separate them. So 1 over sine squared is cosecant squared. And then I'm actually going to rewrite this a little differently. I'm going to write it as cosine of x over sine of x times 1 over sine of x. Because this part, sine squared, literally means sine of x times sine of x. So there's 2 of them. And now I get cosecant squared minus cosine over sine is cotangent, and 1 over sine is cosecant. And then that's my answer with 0 fractions. Okay, let's try another one. So same idea. We need to multiply this by the conjugate. So when we multiply this by the conjugate, we have to be very, very careful and do our steps very carefully. So I'm actually not going to multiply the numerator out yet. I'm going to write this as cosine squared times 1 plus sine of x. And I'm doing this in hopes that maybe something might reduce off. When I distribute out the denominator, I get 1 minus sine squared. And so this should jump out, and you can be like, oh goody, I'm going to get a good answer. So 1 minus sine squared, using our Pythagorean identities, is going to be cosine squared. So you get cosine squared, and then 1 plus sine of x, all divided by cosine squared. So this is just going to reduce off, and you end up getting 1 plus sine of x. And you're all done. Okay, on your own, I want you to try these. Don't be scared to multiply by the conjugate. Just be very careful when you distribute or choose not to distribute. So go ahead, take a second, and try these on your own. All right, let's do A. So I'm going to multiply by the conjugate. So I get secant of x minus tangent of x divided by secant of x minus tangent of x. So I'm not going to multiply the numerator out quite yet. I don't think that I'm going to need to. So this is secant of x minus tangent of x, all divided by, now with the conjugate, you do the first term squared. So secant squared minus the second term squared, tangent squared. Now, at this point, I have a trig term squared. So I should think Pythagorean identities. So I'm going to write down my identity that has to do with tangent and secant. So tangent squared plus 1 is equal to secant squared. So notice that I have a secant squared here and a secant squared here. So I'm going to replace this secant squared with tangent of squared plus 1. So I get 4 secant of x minus tangent of x, all divided by secant squared becomes tangent squared of x plus 1 minus tangent squared. And then the tangent squares are going to cancel off. So I'm left with 4 times secant of x minus tangent of x, all divided by 1. And so my answer is just 4 times secant of x minus tangent of x. All right, and last problem, 1 plus tangent squared of x, all divided by cosecant squared of x. Okay, so we know from our identity that we just used that 1 plus tangent squared of x is equal to secant squared of x. So this whole numerator is actually just going to become secant squared. So then I get this is equal to secant squared. Again, the numerator 1 plus tangent squared is secant squared, all divided by cosecant squared. Now, I don't like dealing with secants and cosecants, so I'm going to rewrite that as sine squared over cosine squared. Because secant is 1 over cosine and cosecant is 1 over sine. And sine over cosine is simply just tangent squared. And that's it. All done.